Hello, everybody. Welcome to the On Orbit podcast. My name is Jeffrey Hill, Executive Chair of the Satellite Show. And before we start the episode, I just wanted to remind you that Satellite is less than 8 weeks away. It starts Monday, March 10th, and runs through Thursday, March 13th at the Washington, D.C. Convention Center. I also have a very exciting announcement. We have just confirmed that NGA Director Vice Admiral Frank Whitworth will be the opening keynote speaker of our new GovMilSpace program. GovMilSpace at Satellite is our expanded government and military forum program, including 16 conference sessions, a dedicated breakfast keynote, and dedicated exhibiting space on the exhibit hall floor. We are honored to have Vice Admiral Whitworth as our opening keynote, which is produced in partnership with our friends at Defense Daily. For more information on Satellite, GovMilSpace, and Vice Admiral Frank Whitworth's keynote, please visit us at www.satshow.com. That's SATSHOW.com, the Satellite 2025 Conference and Exhibition in Washington, D.C. Get in early and register for the show, and we'll see you all in March. And now, on to our episode.
You often hear space described as congested and competitive, but Brien Flewelling likes to describe the situation as dense, dynamic, and deep. It's dense as there are more spacecraft in orbit, deeper as spacecraft are now in more orbits, and it's more dynamic as spacecraft are maneuvering more frequently. As Brien says, it's not your dad's space domain awareness. Brien is the Director of Strategic Program Development at ExoAnalytic Solutions, and he joins On Orbit this week for a conversation about space domain awareness. We look at specifically how NATO coordinates in space domain awareness, and he shares takeaways from the NATO Edge and Spacepower conferences in December. I also asked him what really happens when a satellite breaks apart in orbit, how on-orbit decision-making is evolving to become more autonomous, and how space domain awareness can keep pace with everything being launched to orbit today. I'm Rachel Jewett, and you're listening to On Orbit, the podcast that asks, what's our future in space? Hi, Brien. Thanks for joining me on the On Orbit podcast.
Hi, thanks for having me.
Yeah, awesome. So we are going to have a discussion today about space domain awareness, particularly in the context of the NATO alliance, and I'm excited to hear more about that. But before we dig into it, tell me a little bit about yourself and your work at ExoAnalytic.
Sure. I've been involved in all things space now for going on 20 years. I found it fascinating as a kid in high school and researched it all the way through grad school, and have been interested in it from watching spacecraft do proximity operations and computer vision and all kinds of other kind of cool technical areas to do research in. I was a research aerospace engineer at the Air Force Research Lab Space Vehicles Directorate. It's kind of my first job in my career. So with the research that I'd done, there was other areas of application that they were interested in, and one of them was space situational awareness, which at the time described kind of where are these satellites and pieces of debris, and where are they going, and can we predict their orbits and provide sufficient notification that there may be a need for a change in the operations of an active spacecraft in order to avoid a potential collision. They tend to call that a conjunction. That was historically a mission primarily performed through the 18th Space Control Squadron and through others within the then Air Force Space Command and other organizations, because there was kind of a military need to understand. The Russians had launched Sputnik in the 50s, and is that object something that could re-enter, and could it be a missile, or is that object just a spacecraft doing various communication type things in space? And so I would say space situational awareness evolved from that. And then kind of what we call space domain awareness today is, again, a mission focused on kind of the needs of the U.S. Space Force in terms of how do we maintain an ability to preserve, U.S. Need to operate as they need to into and from space there. So it's more of an understanding of what is going on up there. They're evolving debris fields. I'm sure we'll get into that. The threat posed by adversary nations who are also fielding other space systems that are behaving differently than spacecraft have in the past. And I've worked in this area now for more than a decade. I've been with ExoAnalytic about 9 years. So I'm now their director of strategic program development. So finding new and interesting applications of our technology. So how do we sense and make sense of what's going on in space from a network of 400 plus telescopes that we operate and maintain privately? And then how does that information effectively inform good decision making, whether that's responsible decision making so that you operate your spacecraft effectively and avoid potential collisions with debris or what have you, or an assessment of some of those interesting behaviors that we've seen spacecraft execute. It's primarily in geosynchronous orbit, which is an orbit where spacecraft go around the Earth at the same rate at which the Earth rotates. So from the ground, they appear to have a fixed position in the sky. That's why you can have a fixed satellite dish and point that dish at your spacecraft, like your DirecTV, for example. And it doesn't have to move to track the satellite, right? So very expensive satellites are up there. Very important satellites are in those orbits. And, we just saw a recent launch. Congratulations to Astronis. Just put 4 up in the same launch over the weekend on the SpaceX launch. And we're excited to keep supporting those safe operations and informing as both the debris hazard populations evolve and the activities of those spacecraft get more complex and interesting to interpret.
Yeah, and with just more and more satellites going up from, all around the world, I'm sure that it's the environment is getting only more complex, and this is just of such increasing importance, space domain awareness.
Yeah, it's complex from a number of angles. You may read, when you read about space domain awareness, you'll hear about congested and competitive. And I like to use the terms dense, dynamic, and deep today because space traffic is getting denser. There are simply more spacecraft in the orbits that are more frequently used than there used to be. They're more dynamic in that they're maneuvering more frequently for various reasons. That may be to avoid each other, to avoid debris, or to do different things in their mission. So whereas before you might have sent a spacecraft to a single orbit and trying to maintain a perfect representation of that orbit over the lifetime of a system, you might now today send a spacecraft to one orbit and then maneuver it to another one or service another satellite or do a number of different things over the lifetime of that satellite. So that just increases the frequency with which satellites are using fuel or electric propulsion or what have you to execute their operations. So that's the dynamic piece. And then the deep piece is we're not just going to GEO anymore, right? So yes, we see many satellites going to low Earth orbit, but we're also talking about new orbit regimes like VLEO, very low Earth orbit, or XGEO, meaning beyond geosynchronous orbit, or cislunar type orbits, where then the gravitational complexities of the three-body problem become part of the tracking process. So yeah, and every one of those changes for the way in which we're using satellites, the increase in the complexity of satellite operations is providing a commensurate increase in the complexity of satellite tracking, whether you call that space domain awareness, space surveillance and tracking, or what have you.
Okay, so you said dense, dynamic, and deep.
Mm-hmm.
That's very interesting. I like that. And then, okay, so just before I want to ask some questions about the NATO summit that you attended, but in short, how do you define space domain awareness? And is it the same as space situational awareness? Do those things mean the same thing? Kind of what's the definition?
I think it's important to ask the authorities that generate those terms to go to their kind of literature to define that. And I don't have it in front of me to quote it well. What I will say that is that space domain awareness is itself a mission as described by the United States Space Force. There's also a space traffic management or space traffic coordination, which is a term that's used by the Department of Commerce to describe coordinating the activities of spacecraft with the same, more or less the same intent, which is to operate responsibly, avoid unintended harmful interference, be it physical or RF interference, avoid conjunctions or collisions with hazards like debris, etc. And I would say functionally, it's kind of all the same in terms of supporting it from a sensing standpoint, right? You want to observe where these spacecraft and debris and everything else up there are, understand their orbits, understand their maneuvers and their behaviors. If they change their orbit, why did that happen? Was there a mission reason for that? Are they intending to get closer to another object in space? Is that object aware that they're going to get closer to them? Maybe they're a client of a satellite servicing mission, and that totally makes sense. Maybe there's a dead piece of or a non-functional satellite in GEO that needs to be removed. And depending on kind of the perspective and the rest of the context around what's going on, you're going to get a wide-ranging set of opinions about what all of those activities may mean. But again, from that sensing standpoint, you need to sense, make sense, and then support the decision, right? What's happening, what changes have occurred, who might need to know about those changes, and then does that mean something to you as the potential operator of a satellite? Does that mean you might want to maneuver your satellite? Does that mean you might want to communicate with the owner of the other satellite or communicate with some form of authority to say, hey, I'm not happy that that satellite might pose an undue risk to me. What are my recourses there? So I would say, generally speaking, space situational awareness, space domain awareness have kind of been the terms that have been used to describe this process. But things have been changing in space so quickly in the last several years, and it's being done, at a speed and scale that it's not been done before. As time goes on, that whatever term you prefer, I would just say that it's not your dad's SSA. It's not your dad's SDA, right? It's faster. It's more complex. There's more nuance. There's more countries involved. There's all kinds of things that effectively and precisely understanding what's happening up there is just a part of operating responsibly in a remote operating domain.
Yeah, that's a great point about how much it has changed in recent years. So you wrote a piece that Payload published, and I'll link it in the show notes for listeners, talking about how NATO needs to make shared space domain awareness a bigger priority. And so this was ahead of the NATO Edge event, which was held early in December. So kind of what is the situation with NATO and space domain awareness today? And why do you think that there's not enough emphasis on that?
Well, there's not enough emphasis because I would say across the board, I would argue for more emphasis. It's not a criticism of NATO at all. They have, as of 2018, stood up or recognized space as the fifth operational domain. They've come out, and I think in 2022 with a space policy. They're looking at integrating commercial into that as are other major organizations writing their very first kind of commercial integration policies. They've established a space operations center and a space center of excellence. I will say that these are all kind of new endeavors that they're taking, but the threat gets a vote and they're not waiting. Like the rate at which China, for example, is fielding their space systems, and the rate at which various space forces around the world are grasping with these problems, and then at the level of NATO needing to work together in terms of different levels of classification, different language. There's lots of potential challenges in coordinating what is already a very complex problem there. So, it was more of the op-ed was to highlight the fact that yes, this is a priority. Things are accelerating, and the criticality of space to future conflict generally is important to understand, and it's important to stress that it should not be an afterthought when other terrestrial operations may have a dependence on space services or services derived from spacecraft. Not every nation has their own spacecraft today. NATO doesn't operate their own spacecraft today, but certainly being able to pull together a composite awareness of what resources are available and what clients there might be that would be impacted if any of those services were degraded certainly is something that would be good for NATO to understand. I was just at the Space Power Conference a couple of weeks ago as well. They had Air Marshal Godfrey speaking. So was from the UK, but is here in the US as a deputy chief of staff for partnerships. His top priorities that he talked about were information sharing, particularly with the CSPO nations, the combined space operations nations, and NATO nations, right? So NATO's the larger set, so it's easier to talk about it in terms of NATO because it encompasses all 32 member nations to the treaty. Mm-hmm. But being able to get on the same page from available information so that decision making and coordination can occur quickly. That can start with unclassified or not classified data, which commercial space domain awareness data happens to be. But then there are further opportunities to layer the additional information that may be provided to NATO from various countries. So having a common baseline of an awareness that could be derived from non-governmental sources, and then being able to use that to dialogue with each other so that, the allocation of their either sensing resources or whatever they may have to contribute to NATO, that decision making can be supported more quickly, is something that we're interested in at EXO, interested in having that discussion, right? How can data that we provide to the US support NATO? How can we add more value so that it's provided in the right context and that it's coming into the multi-domain operations context, right? Yeah.
Mm-hmm. Yeah, I mean, there are all these different governments trying to work together, and the different countries have different commercial capabilities that might be involved. So it sounds like there's so many layers of coordination. How do you think that could be improved internationally?
Well, it's kind of the same way when we started a company and built our own network, you kind of learn by doing. Right? I think sometimes we end up into this situation where we're paralysis by analysis kind of a thing. We're so busy trying to field the perfect thing or to make sure we've taken care of all of the possible angles that we forget to just field capability and learn from doing it. And I think NATO actually does this with exercises and other things quite well. But I would say that's kind of the thing is we stress to our customers is put us on the field, coach, right? Like, if you're trying to get a quarterback from your team, you could have us all write you a 30-page essay about why we'd be the best quarterback, or you could just throw some footballs out on the field and let's see if we can, connect on some passes. I think we are in that state where there's technology to be brought to bear and ways in which that technology can be enhanced between cloud, AI, you name it. We've seen the impact of drones in Ukraine, things that were, not too many years ago dismissed as, potentially not impactful technologies for warfighting are now kind of changing the landscape of the way things are done today. So, there is an equivalent of that for space, and it's something that we should not be slow to learn, right? We should be able to employ the capabilities that we have so that we can come up with better ideas about how to generate the systems we may need in the future.
Mm-hmm. Yeah, that's a great analogy. Just get the players in the game. Be testing these capabilities. What were some of your impressions from the NATO Edge event? And I understand that it wasn't a space focused event. Space was just one of the threats that you were there talking about, and others. So what were some of your takeaways from that event?
Yeah, so I've been to the last two of those events. This was the first time in maybe, but at least some time that it's been in the U.S. So it was in Tampa. I was at it in Mons, Belgium in 2022 as well. And I think, the first takeaway is, it was impressive how much more coordination and how much more kind of capability across the board that you're being shown, and that not just the context of space or space for space's sake, but you really do get this understanding that there's a kind of a means to an end here. Like there's a reason these space services are so important, because it impacts the terrestrial fight. It impacts how forward operating forces might behave, and it was a great event this year. Certainly, I came away understanding that, NATO does seem to be prioritizing space. They've in the process of establishing or have established multi-nation efforts. I happen to be in the pool of innovators for their Diana program, which is the Defense Innovation Accelerator for the Northern Atlantic program. So there's a focus on getting these innovative ideas out there and working with everyone from small businesses and startups to others who have supported NATO more directly for years, to big cloud providers and big AI providers. It was very cool to see the folks in the exhibit hall who are demonstrating some of these technologies and making sure they can map it to kind of NATO needs, and then being able to have those people interact with kind of some of the more cutting edge approaches to networking these systems, to informing these systems. Hopefully what comes out is kind of quality options to kind of equip the warfighter or the NATO warfighter, with future capability as quickly as possible. So I was on the SDA panel. We had a great discussion that was kind of, what does a breakup in geo cause? So there was a recent event with the Intelsat 33E that caused hundreds of pieces of debris to join the population of objects that will be up there for a very, very long time, and will have to be contended with by all operators at GEO for, it's, we talked about how, important it is to look from a multi-domain or a multi-phenomenology perspective. So not just telescopes and optics, but from RF and cyber, and what are the potential vulnerabilities to the satellites. But further, if one satellite has its service degraded, what does that mean on the ground? Well, it might mean that some naval vessels might not have their comms, or it might mean that a battalion of people on the ground can't reliably navigate the way that they wanted to, or have to go back to kind of backup approaches. So, I think it was fascinating discussion. And, I speak very little German. I am not multilingual in the least, but just being impressed by the number of folks who do speak multiple languages, who are talking about this technology and trying to bring it to bear in their home nation at the same time as, collaborate in such a way as to support the alliance. So it's a great event, and it's one I look forward to the next time it happens.
Yeah, that's really interesting. And were you getting, was there conversation about how space fits in with space capabilities fit in with other defense capabilities, and like how it's all part of a cohesive defense strategy and not just space is over here, another domain is over here?
I would say space and cyber both kind of have that um, uniqueness about them, that they're still being normalized within the broader kind of joint force context or a NATO context, right? They're new to the party in the sense that, for a long time, space was considered a benign domain. We wouldn't see, warfighting extend there, and maybe we had a good long time where that was more or less not the case. But and cyber kind of the same way. It's one of those things that you need a special set of skills to understand how to kind of bring cyber options to bear or to defend against them. And so to have everybody in the joint context understand and be skilled in cyber, or to have cyber people skilled in the rest of land, air, and sea, like that's something that's still in process. And I certainly think I interacted with many different NATO folks who certainly there is an appetite to kind of bring in space into that picture in the same way that you might bring in cyber and other things, and to appreciate what space brings to the fight. And oftentimes when you go to exercises or war games or something like that, there'll be these assumptions that, oh, well, the space stuff is just working, or this is just there. You're going to get this information and this. It's like, well, how do I know that? Well, it came from the space service. Well, yeah. So space is one of those things that, if your assumptions are that it's there and it's not degraded and that's all just going to work, then you're kind of just operating under the most optimistic of assumptions. And so integrating that into that multi-domain context becomes important, because you can at least say, well, if that's not true, now what are you going to do? Right? Or if there's a likelihood that this space service could be degraded or destroyed, how does that affect your planning? Who do you need to tell that could happen? What are the downstream effects of that happening? And then how does that affect logistics? How does that affect a number of other things that might be important in a protracted kind of long-term conflict? And then, the U.S. has enjoyed the ability of space to enhance our ability to project combat power now for decades. Adversaries have recognized that, and they're also building their own space capabilities and counter space capabilities. But it's now getting to a point where, what you can do in space also enables new capabilities for the adversary. So where you couldn't be threatened from as long a distance before, now maybe you can be. And if you're going to plan how you're going to operate in a conflict where that adversary is that much more capable, that may reorder some of the steps of the things you might do. I'm not speaking with any direct knowledge of any of that, but certainly it gets more complex when you have to admit that, you're not the only one with like over the horizon navigation or any of these kinds of things. And so, yeah, it gets increasingly more complicated just in not a NATO context, to make sure you're considering space as part of the whole part of the problem. But then when you talk about having to do that and help everybody else in an alliance understand what it means to bring space into your thinking, there's a lot of ways in which that can get lost in translation,
Mhm.
literally and figuratively. Uh,
Mm-hmm.
and it's going to be an important discussion to have.
Yeah, no, those are all really interesting issues. Are there some practical suggestions, like real world things that you would like to see changes in better shared space domain awareness within the NATO alliance?
I, Again, we're still learning by doing. We're
Yeah.
working with folks in the U.S. Quite closely, and we're excited to hopefully support kind of Air Marshal Godfrey's vision of extending that data and information to be able to be shared across NATO and other allies. But we also want to be uh, fight. I would say one of the practical things I want people to consider is the we've had a long time where this process has been somewhat open loop and certainly somewhat human in the loop, and that there's always been lots of time to make these decisions. Um, Secretary Kendall in the U.S., he's the Secretary of the Air Force, has stressed that this may not always be the case, right? That we may be needing to move someday toward more autonomy, more space systems that can make their own decisions quicker. It's been in the news about SpaceX making kind of autonomous maneuver decisions to avoid not just each other, but other satellites and debris. And how do you do that quickly at speed and scale? Um, so as space traffic is getting more dynamic, more dense, more deep, the likelihood that these decision timelines get much, much shorter is pretty high.
Mhm.
So there's the potential to need to move toward more autonomous decision making. And
Mhm.
that then means that you need to kind of integrate these information services so that you can fuse off-board sensor data with potentially onboard sensor data. And, how are you going to train the brain that's on that autonomous space system? What do we need to do to trust it to a point where you'll actually deploy it into that type of a conflict situation? And, is the adversary doing that today? And how do we interpret that? And what does it mean? So there's some form of, you know, autonomous drone analogy coming for space. And, how do we get our heads around that? How do we inform it reliably, responsibly? How do we make sure that it's making the right types of decisions given, the phase of conflict, what we may be in? It's given the different priorities that might be there. And is that different decision making for one country versus another? There are cultural aspects of that. So it's a complex problem, but the physics are leading us toward needing to get to a point where the decisions can be made faster.
Faster.
And so we may not have the luxury of time in all cases
Mm.
for a operator in the loop. They may have to be on the training loop and understanding that this machine can now make effective decisions. Um, and while they'll operate in the vacuum of space, they shouldn't make those decisions in a vacuum. How are we feeding them the information they need to have? So there are those that call that a perception layer. Like how do we maintain a precise perception layer for autonomous systems to make good decisions? That's something that we at EXO are looking at. That's where that space domain awareness is kind of heading, is how do we make sure that the space systems, whether they're operated by humans or making their own decisions, are making those decisions on the basis of good information.
Hmm. Yeah, absolutely. You mentioned talking on the panel about the Intelsat satellite
Hmm.
breakup, and then there was another like defunct weather satellite
Hmm.
recently that broke up. So what happens when a satellite breaks up, and why does that happen?
Yeah, so it can happen for a number of internal or external reasons, right? And just because you might be able to point a sensor at the sky and see the result of a satellite breaking up, right? Seeing multiple pieces where once there was one doesn't mean you have all of the answers. You can kind of bound by physics whether or not you thought it was an internal or an external cause, but you don't have all of the information. So the best that we like to do is to be able to provide the observation data, the characterization data, whatever we have, so that that type of a after event analysis can be done in kind of more of a meaningful way. But what can happen has to do sometimes with electrical harnesses on the spacecraft could spark. You could have propellant kind of clog issues or frozen propellant that happen on spacecraft occasionally. You can have kind of different heating and cooling. The heating and thermal and radiation environment in space is pretty severe depending on kind of what orbit you're in, but it's no vacation I want to go on without sunscreen, right? So you're in a pretty extreme environment, and while responsible spacecraft designers are always looking at ways to kind of design for demise and pick the right materials and try to come up with ways of manufacturing these things to minimize the likelihood that this happens. It has happened occasionally. It can also just be hit by a piece of debris, and that piece of debris could be relatively small and could be going quite fast. And so high velocity impact of something small, one, if it's small enough that it's hard to detect, you didn't know it went in, all you saw is the result of that small piece of debris hitting the spacecraft. That is a plausible explanation, and it's a hard one to rule out oftentimes. But there are hints, right? If it breaks up slowly, it didn't just explode all at once. If the direction that all the pieces, there's a preferred direction that all of the pieces seem to go, that's different than if it went in all directions at all at once. And there's certain things you can tell from the motion of the objects that you observe, but it's not everything. It's kind of the what happened, not necessarily the why.
Yeah.
That happened. And so, more or less you can kind of rule certain things out, but you can't come away and say this is definitely what happened, which is where other technologies like satellite inspection services and other things like that, it can give us better understanding. Like when we've seen small pieces of debris hit solar panels on the ISS or things like that, you can see evidence of, what the actual degradation was to the spacecraft. And it's not always a whole satellite ends up into hundreds of pieces. Sometimes it's maybe it still causes the satellite to not work anymore, but it's still up there and it's still just kind of drifting. I like to say all satellites are aspiring debris, right? At some time they won't work anymore. They'll have run their useful lifetime out, and some part of the environment will have won, right? The solar panels will have not get a charge anymore, or something, right? And so that's an important thing to think about when you think about GEO, because what is typically done is at the end of a lifetime of a satellite at GEO, you boost it up about 300 kilometers higher, and we just leave it behind, right? And so all of the objects that have ever been more or less flown at GEO are
still there.
Still up there.
Mm-hmm. Yeah. So when a satellite breaks apart, that debris, it just becomes, like you said earlier, more debris that's up there that the operators have to contend with and avoid.
Yeah, more or less. Like I said, if you are able to deorbit or move to what they call the graveyard orbit, that's less of a concern over a very long time scales. Perturbations can make even those objects potentially cross GEO at some point, but the frequency they're at the orbit altitude of GEO is still relatively low. When you have a failure and the satellite is still at the geosynchronous altitude, or the debris is at that altitude, then you will have to contend with that object. So we've had satellites that have been called zombie sats, where they're not able to talk to it anymore, and it's not sure if it's alive or dead, but it's wandering through the through the geobelt, and then we've got these pieces of debris that, yes, there was what a force was imparted on the new pieces of debris when the satellite broke up, and it changed all of those pieces of debris' orbit just slightly because their mass is now different, and there was enough energy imparted to each one of them. But a lot of those orbits come back across geo. And so you would like to have a good understanding of the orbit of each one of those objects, and you would like that understanding to be precise so that you know whether or not two objects might actually get close enough to be concerned. So you'll hear a lot about conjunction warnings that say, hey, we tell spacecraft all the time, or the Space Surveillance Network or the Open Catalog or other conjunction services may provide a warning fairly frequently that you could be impacted by a piece of debris or another satellite. That's not just the fact that these objects are getting close, but it also has to do with how well we understand the actual orbits of those objects, right? So the less certainty I have in the position and in the velocity of a spacecraft or a piece of debris, then the more space that I have to kind of assume that the object might be in at a particular time. So that we call those covariances, which just has to talk about kind of what are the error bars in position and velocity of that object. So it could be here going this fast, or it could be here plus or minus some distance. And it could be going this fast or a little slower or a little faster, right? If I was going to tell you, hey, don't cross that intersection right now, there's someone that might be coming the other way, but I couldn't tell you exactly where he was, how confident would you be wanting to push the gas, right? It's that kind of a thing, right? You're telling an operator there might be something near you at this time. Maybe. And what they're going to want to know is, well, how precisely do you know that, right? And so a lot of the observations that are taken are to maintain a precise knowledge of those objects, so that if that object were to maneuver or turn the steering wheel, it's not confusing. Yeah, it clearly did maneuver, and we can characterize how that maneuver happened, and now it's going this way, right? And so you can imagine then, if you don't have precise knowledge of lots of objects, and those objects are doing lots of little maneuvers or changing things, then that lack of precision makes a clear understanding of what's happening with all the objects in the traffic hard to describe, right? Like, you're going to want to know that each car is an individual car on the road, and they're all driving this fast in these directions, and that's when you start to describe rules of the road and all of these other sorts of things to kind of come up with ways in which these more complex traffic patterns can be safely designed, so that more people can use that traffic ecosystem. So space is in that exact situation right now, where all of the autonomous cars are trying to figure out what the right way is to deal with the presence of everybody. Right?
That's very, very similar to autonomous cars. So with ExoAnalytic, you guys operate a network of telescopes that are observing what's happening in space.
Yes. So we have about 400 telescopes distributed across 37 or so sites around the world. We watch objects, we like to say about 8,000 kilometers and above, so not low Earth orbit, though we can take a telescope and look at any given object of interest in low Earth orbit. You have to wait for those objects. I was out at 5 this morning, and you could see satellites overhead. I think the ISS passed over this morning, which was kind of cool, but you only get that time at dawn and dusk, where the objects are lit by the sun and not in the Earth's shadow. And so for optical observation, low Earth orbit just doesn't have as high of a duty cycle, where geosynchronous orbit, we can look at any given object in geo for around 18 hours per day from somewhere on the planet, right? So that's a much more persistent, kind of what we call a persistent dedicated service, where we can understand the behavior of that object for a much larger fraction of its lifetime, not able to look only when the sun is right behind it. right? So that becomes important when you want to understand more complex questions about the behavior of space systems, right? Why are they operating it this way? Why do they take a break every Tuesday? Why do they, right? There's these kind of thing questions you might have that if you can't figure out how is that object maneuvering, it's hard to answer all of the additional kind of higher order questions that you might have about what the actual use of a space system might be.
Okay, very interesting. And I know that there are a couple of commercial companies doing this, and governments are doing space domain awareness. Can space domain awareness keep pace with all of the satellites being launched? I mean, more satellites in LEO. China, nations that might not be sharing their space domain awareness information. How can space domain awareness keep pace with all of this?
So I think this is an excellent question. And I think the first thing that we need to, I kind of want to rephrase it a little bit.
Sure.
Right? Can we keep pace with the growing traffic ecosystem with the same sensors?
Okay.
Right. And I think generally speaking, you can do the best you can if you keep the sensing infrastructure fixed, but you're basically taking limited resources and spreading it over an increasingly difficult problem. Right. So the idea that a fixed number of radars and telescopes and things like that can handle the problem as the problem is getting continually worse, most people listening would probably say, well, why wouldn't we just go get more sensors? Right? Why wouldn't we? And so that's kind of where the commercial stuff started, a decade to a decade and a half ago, was just as this problem is expected to get more complex, one of the things you can do in any problem to reduce the uncertainty is measure the thing you're interested in more often. And so that's kind of the first step. Is I think what we've learned about the process of doing space domain awareness is you can keep up, but not if you're constrained and you're not doing a commensurate, say, investment or scaling of the sensor resources to the draws on those sensor resources, right? I need to keep up with more satellites doing more things. And then should we be doing it the way we've always done it, right? Should we be looking only with telescopes from the ground and only with some certain number of radars? And what other technologies can we bring to bear? How many more space-to-space observations should we be taking, for example? And there are limited cases of people fielding space sensors to do this. There's some that are out there that are well known, but there are also other kind of programs looking at, well, if there are more sensors looking at everybody from different directions, how does that help the problem, right? And one of the things that helps is, we call it geometric diversity. If I want to know right now where you are, it's better to take a measurement from multiple directions to you than just one. Right, because I can kind of limit in one direction how far I think you are away, but then there's other kind of uncertainties in the direction I didn't measure from that aren't being accounted for. In space, if you wanted to get at a precise orbit, but you only looked from one sensor location, usually what happens is you have to wait for enough time to pass so that that space object moves far enough for you to be confident in that object's orbit.
Okay.
Well, that's great, except that object might maneuver in the time it takes you to be confident that whatever it was doing, right? So you're in this race between how fast can I understand that object's orbit and how quickly will that object just maneuver again, right? So with geometric diversity, you use sensors from different locations looking at the same time. Now I don't need to trade time for a new understanding of that object's motion. That's going to need to be the coin of the realm, right? You're going to need to be able to say, I know what you're doing now, without having to wait for that to happen, right? So if you turn the wheel, I know you're going that way, right? Not, give me 20 minutes or give me, give me 4 hours and I'll get you a good orbit estimate again. That doesn't work anymore. So whether that's between here or out to the moon, you're going to need that geometric diversity. You might need that diversity in sensing modality, so radars and optics and some of those kinds of things, so that you can converge orbits on all of these maneuvering spacecraft as fast as you may need to do so. That's another way of just expressing what I'd said before, is that it's not your dad's space domain awareness anymore. Right, like it's more like the movie Everything Everywhere All at Once kind of a thing, right?
Yeah.
So it's also one of the things I said on the NATO panel was, we've called these things space domain awareness, but it's really just kind of a inherent function of operating in the new space domain.
Yeah.
Like if everyone on the road is driving self-driving cars, they're terrified of your grandma showing up in her 1952 Chevy truck, merging on the highway. What protocols is she communicating on? Does she even have sensors on her truck? How, what is she going to do when we're out there? And that's kind of the same thing here is, in order to consider yourself a member of modern space traffic, do you have to have some level of participation in space domain awareness, in either measuring other things, receiving information about what's been measured about you and others around, so that you can use that the same way you get that blue dot on your own device when you're trying to navigate from A to B in your car. This would be the same kind of thing.
Yeah.
Right? Wherever that comes from, you need that information service to operate effectively and safely around everybody else.
Yeah, absolutely. You've got some great analogies. I mean, I definitely commend ExoAnalytic and the other companies doing this, because it is a very complicated problem and only getting more complicated as more things are launched to orbit. It was great to talk with you, Brien. Thank you so much. Any final thoughts?
A lot of people will hear what I'm talking about and they'll wonder if space is crowded. I'll just say, no, it's actually big. What the reason it feels crowded is the ignorance left from not measuring some of these things often enough. So investing in and scaling the sensor contributions to the solution, being able to maintain a precise perception layer for space should be the goal. And this is a problem that's kind of reached its time. I'm hoping kind of 2025 is the year for modern space domain awareness, space sense making, autonomous space systems. It's an exciting area to work in. If you have interest in any of these things, I'm happy to have you reach out to us at ExoAnalytic, and we'll be happy to get people educated or connected. And like I said, the problem's not getting any simpler or smaller, and we'll be here to help people operate anyway.
Awesome. Well, thank you so much. I really appreciate it.
Thank you.